Looking pretty good so far. Notice that at that far wall is the polished board, not the back side of it. It's working. This room is about 20 feet wide, 30 feet long. So my next move is going to be to stop the car, using the radio transmitter here, and I'll try to bring the car back to me a bit. I'm just showing you that I can still run it by the radio control. And I'm going to change the pot. I've increased the pot, increased the speed a little bit, I hope. We'll see what happens. It should be a little faster. Okay, that's it. Here are the details of the kit that goes on top of the 1/10 scale model level radio control car. Below the skin is a regular radio control car, which electronics consists of a radio receiver, a steering servo, and electronic speed control, which in fact controls the DC voltage to the wheel driver DC motor. There is also one battery. It's 7.2 volt lithium, and it powers everything, including the electronics in my kit. I have disconnected the three standard 3-wire connectors that under the skin normally go between the radio receiver, electronic speed control, and the servo, and brought them up through holes in the skin. They are the three little black connectors that you can see here. This one, and this one. Two of these now go from the Arduino, which is this chip, or this printed circuit card, and that little square right there is in fact the microcircuit chip itself, which is hugely powerful and about maybe 3/8 of an inch square. It drives this and this, one of which goes to the steering servo and the other goes to the electronic speed control. From the radio in the car, this connector feeds information to the Arduino. All of this is wired together using what is called a solderless prototype kit, and you can purchase solid gauged wire of different lengths bent correctly to hook up the wiring. And as you can see, there isn't very much. And some of those wires are connecting ground and DCC. So there's not very many wires involved here. Also, in the front is a sonar distance sensor, and here is a sonar distance sensor over on the right hand side. Oh, and by the way, this antenna here is the antenna that goes to the radio, because when I turn the radio transmitter on, it takes over controlling the car, because the computer detects that the radio transmitter is on and says, all right, it's yours. So the sonars work with echo of ultra high speed sound, ultra high vibration sound, and at 1100 feet per second with a clock speed of 1,000,000 per second, the sonars can get a very accurate measure of distance, up to maybe, I'm not sure, but at least 15-20 feet. They have a bit of a problem because they're not 100% directed, and so sometimes if they are, oh, by the way, how are they put together? How's everything put together? Velcro. There's Velcro right here, but most importantly, this whole package is Velcro to the top of the car. There's also one potentiometer right there, which the computer uses, or I use, to tell the computer how fast should be the fastest speed the car can go. The pot only deals with the top speed, and that's what I fiddle with when I try to make the thing work at different speeds in the racetrack. Total cost, Arduino is about $35. The sonars each are about $28. The prototype board is, I think, $8. That's about it. Oh, you can buy, actually, come with the prototype board comes a series of those little carefully bent wires. So that's it. Somewhere is under $100. You add this kit, and you have a real, honest-to-goodness robotic car. Thank you.